let's look at finding the derivative of tangent. Tangent is sine over cosine. So if I want to take the derivative tangent, I could take the derivative of this quotient of functions, the sine over cosine. As a reminder, if you are looking at the derivative of f over g, it's the derivative of f times g minus f times the derivative of g all over g squared. So in this case, I'm going to be taking, since this is a quotient, I'm going to use this quotient rule. The derivative of sine times my bottom function cosine minus my top function sine times the derivative of my bottom function cosine. And this is all over the denominator squared. The derivative of sine is cosine, so this gives me cosine times cosine. The derivative of cosine is negative sine. So taking the derivative of the first piece and the second piece and putting those inside of the quotient rule gets me here so far. Let's see if I can simplify and make this look a little bit nicer. Because I have cosine times cosine, that's cosine squared. A negative times a negative, that's going to make this a positive. Sine times sine is sine squared. I've got sine squared plus cosine squared. That's the Pythagorean identity. Sine squared plus cosine squared is 1. So I can replace the top of that fraction by the number 1. Finally, 1 over cosine is secant. So that's secant squared. So this tells me the derivative of tangent is secant squared. Again, to come up with this, I set up the difference quotient, because tangent is sine over cosine. Derivative of sine times cosine minus sine times the derivative of cosine, all over the bottom squared. I simplified, and I ended up with the derivative of tangent is secant x squared. If you've seen that formula before and wondered where it came from, you could use the quotient rule to get that formula. Let's check out some more examples together.